Hello everyone, today we are going to discuss the problem rectangle cutting. Given a cross B rectangle, your task is to cut it into squares. For each move, you can select a rectangle and cut it into two rectangles in such a way that all side lengths remain integer. So you have to tell the minimum possible number of moves from which you are able to cut a rectangle into squares. Okay, so let's take the example of this 3 cross 5 grid. Okay, so what could be the possible cuts that you could make? That is, you could cut right here, you could cut right here, then you could cut right here. This results into a square. That is, you cut right here, right? The second cut you could make right here, right? So by making cut right here, you make two rectangles. You make two rectangles. One is this, and the second one is this. This is a square. So now you have to cut this rectangle into square. So you made a cut right here, which results into two rectangles. That is this one and this one. Now if you have a rectangle of one cross one, or a rectangle of one cross n of one cross n, or if you have a rectangle of n cross 1, right? Suppose there are n rows, there are m columns. So the number of moves that you have to do, definitely m minus 1 or n minus 1, right? So suppose you have no choices, that you have to make a cut for every column or for every row, right? For every row, that is to make it, to convert it into square. So you have to cut 1, 2, 3, 4 if there are 4 columns. If there are 1, 2, 3, 4, 5 columns. So m minus 1 or n minus 1 cuts needed. So this is of 3 cross 1 grid, and this is also a 3 cross 1 grid. So the number of cuts that you have to require, that is 2, 2. So the total number of cuts are 6 to cut this rectangle into squares. Now this is not the optimal answer. This is not the optimal answer. The optimal answer would be, you cut right here, which results this. You cut right here, which converts this rectangle into two rectangles. That is, one is already square. Then you cut right here. Let me draw correctly. One cut is here. Then you result this rectangle and this rectangle. And this is already a square of 3 cross 3. Now you have to make this rectangle into square. You have to cut this rectangle into square. So you cut right here. This is a square. So then you cut right here. So the number of cuts that you did, that is 1, 2, 3, and 1, 2, 3, 3 cuts. So this is the optimal answer. This is the optimal answer, right? So 3 is the optimal answer. So this is the question, right? So let's first try to understand why does greedy doesn't work, right? So suppose you have a 4 cross 6 grid. What greedy approach that is? You try to make maximum size square. You have to make maximum size square. You try to cut this grid into so you have to cut this grid so that you are able to make maximum size square. So the maximum square could be 4 cross 4. So you cut right here to make a 4 cross 4 grid. That is this one. Now you're left with this rectangle. So you have to cut this rectangle into square. You cut right here. So the number of moves that require to cut this rectangle into square are 2. Now this let's try to apply this approach on 5 cross on this grid. So what you could do, that you would try to make 5 cross 5 grid, that is this, right? And you left with this rectangle. Now for this is the rectangle of n cross 1 type. So you have to make 1, 2, 3, 4 cuts. So 4 plus 1, 5 cuts needed. But this is not the optimal answer. The optimal answer would be, you cut right here and right here, right? This results two square. That is one of this, and you left with the rectangle, this one. Now to make this rectangle into square, you cut right here, right here. So the total number of cuts required to convert the one to cut this rectangle into square would be 1, 2, 3, and 4, right? So these are the number of cuts to convert this rectangle into square, right? So in this case, the greedy does not work. So generally, in always greedy doesn't work. So we have to try all possible ways. We have to try all possible ways, right? Now let's try to think, what are the moves that you could do? That is, you could do horizontal cut or a vertical cut, right? These are the two moves that you could do. So let's try to do that, right? You could do a horizontal cut like that. One of the possible, this one, and this one. Let's try to consider this. So if you have a ij cross grid of I cross j, right? Then you could then this results into two rectangles, right? This results into two rectangles that uh, for uh, for that you have to solve, right? For this you have to cut uh, the next problem that you're going to solve for these two rectangles, right? and whatever the minimum you took, you will take for this, right? So let's try to uh, generalize that. What are the rectangles, right? What are the dimensions of the rectangle? Or what after cutting, after makes a cut, what are the rectangles uh, could make, right? So if you cut right here, so you got two rectangles. That is one of this, one of this. What are the dimensions? That is of 1 cross 6. That is of 3 cross 6, right? So you have a grid of 4 cross 6. You make a horizontal cut such that you got 1 cross 6 and 3 cross 6. Now, if you cut right here, so the resultant would be of 2 cross 6 and 2 cross and 2 cross 6, right? So 2 cross 6 and 2 cross 6, right? The next cut that you are going to do right here. So this would result 3 cross 6 and 1 cross 6. So you notice that you could cut on 1 to I minus 1, right? This is the cut that you could do, right? So the dimensions would be f of I h comma j for the first rectangle, right? For the upper one, and for the lower one, the dimensions would be I minus h comma j, right? Where I h goes from 1 to I minus 1. So now similarly for the vertical cut, you got 4 cross 1 and 5 and 4 cross 5 and yes, 4 cross 5. Similarly, if you cut right here, so you got 4 cross 2 and 4 cross 4, 4 cross 4, right? So the vertical cut could be from 1 to j minus 1, and the rectangles you got, that is of I comma v, and this is for left rectangle, and for right one the dimensions would be I comma v minus 1, I comma v minus 1, right? I comma v minus j minus v, j minus v, right? J minus v. Okay. Now this is the possible moves, or this is the sub problem that you are going to solve, right? So you have to took the minimum. But one thing you have to notice that if you make a cut, then you have to add this also. Then you are going to solve now. You make already a cut, so you have to add plus one. So to get these rectangles, you have to make a cut. So you have to add plus one. You have to add plus one, and whatever the minimum, you will take this. You will take that, right? Now let's try to write the transition states. Transition states. So let's first define what TPIJ represents. What TPIJ represents. So it represents minimum number number of cuts required. Minimum number of cuts required. Two. Minimum number of cuts required to cut the rectangle of I cross j into squares. Right. This is what DPIJ represents. So first make the transition for horizontal cut. DP of IJ would be minimum of DPIJ, and we make the cut horizontal. So DP of H j plus 1 plus में dp of I minus h j. This is what for the horizontal cut, and h goes from 1 to I minus 1, right? Similarly, for vertical cut, dp of ij would be minimum of dp of ij, and we cut vertically. So vertical cut dp of ij plus 1 plus dp of I j minus 1. This is the transition that you could do for horizontal cut and for vertical. And the value of v goes from 1 to j minus 1, right? That we saw right here, right? Perfect. Now, the next thing we have to define the base case, right? We have to define the base case. So if you have the rectangle of such that the I equals to j, that is it is I square. It is I square. 3 cross 3, 4 cross 4, right? So the cuts that you're going to do is 0. So for this dp of ij would be 0, right? This is the base case. And finally, we are going to solve for dp of ab. So this is our answer, right? This is our answer. So this is what transition states look like. And this is our base case, dp of ij 0 if I is equals to I. That is, this is already a square, we do not need to cut, right? So the final answer we are going to solve for AB. The minimum number of cuts to cut rectangle of A cross B2 into squares, right? Perfect. Now let's try to code it.
Let's try to code it. We have a cross B grid, right? C A B. Then we have to define the vector of int dp of size a plus 1, vector of int b plus 1 comma b plus 1 comma int max. We have to define it with some maximum number such that we are able to update it with some minimum, right? So next we have to do our transition for int j equals to 1 j less than equal to p j plus plus. And then we have to define first base case. What would be the base case? If I equals to j, then we have to update it with 0, fill it with 0, right? Else we have to do some moves. That is, we are able we could cut it horizontally. We could make a horizontal cut, right? For horizontal cut, the h goes from 1 to h less than equal to I minus 1 plus plus. Right? dp of ij would be minimum of dp of ij comma dp. We have to make a move, that is h, the rectangle that we have, the upper one and the lower one, that is of size h comma j, h h comma j, right? Then we have a lower side rectangle that is of I minus hj, and we have to add plus 1, that we make a cut, right? Now we have a vertical cut, we could make a vertical cut. So for int v equals to 1, v less than equal to j minus 1, v plus plus, then we have to update it with some minimum possible answer, I j dp of I v plus dp of I j minus v plus 1. This is the transition for when we do vertical cut, right? And finally we have to return our answer, that is C out dp of I j dp of ab, what I'm doing, dp of ab, and right. Now this is the code. Let me try it. Let me check it once. Uh, is there any type of mistake or not? Yes, this looks fine. Yeah, this is also great. Hij minus jj plus 1. We have to do minimum. The loop goes correct. J minus iv. Yes, iv. Ij update correctly. Yes, it looks fine. Let's try to run it. We don't get any answer. Why? Is there a mistake? This is correct. This is correct. This is also correct. J from j plus plus, I plus plus. Else we have to make a move. This is h. Right? This has to be h. Now let's try to run it again. I hope it runs successfully now. Yes. The number of moves are 3. Right? Now let's discuss its time complexity. That is time complexity. It is big of O A into B. Right? A into B. And the space we are using grid of size A plus 1 cross B plus 1. Right? I hope you understood it. If it is not, comment it down. I try to resolve your doubts. Thank you.
Until we reach it, all you need to know is that we're holding on. We rise up from